Oh, sneaky question alert, I think. We're given the length of the longest diagonal in a cube. So let's draw this cube just with some lines behind to show the 3 dimensions of it. And what we've actually calculated, what we actually know, is that length there. To work out the total surface area, I'm going to have to work back to finding the length, the single length, but not the length of the longest diagonal. How am I going to do this? Well, let's call the length, I don't know, A. Then the height is also A, and this dimension is also A. How does that help? Because now I need to get an equation for the longest diagonal in terms of A, and then solve it. So let's give that a go. I can actually draw. I mean, if you haven't realized this already, this is going to be a 3D Pythagoras question, because that's how you can relate A to the longest diagonal. I've got a triangle here, and I've got my longest diagonal, which is 25, and I've got a height of A. I don't have this bit here. However, I can draw another triangle, this green one, which I'm then going to put here in 2 dimensions, and this is A, and now I can find the angle of one of the shorter diagonals. I think this blue one's called the space diagonal sometimes, or the longest diagonal, whereas this is just a shorter diagonal. And what can I do? I can write down that it's A squared plus A squared square rooted. So I can add that on here. It's going to be the square root. I'm just going to leave it as A squared plus A squared square rooted. I could simplify it, but I'll show you why I haven't done that in a second. So now, if I work back to the blue triangle, I've got 25, I've got a right angle at the bottom, I've got A, and I've got the square root of A squared plus A squared. This is what I can now write down. I can write down the fact that 25 squared is equal to A squared plus the square, actually let me write that down, the square of the square root of A squared plus A squared, which is actually equal to A squared plus A squared plus A squared. And I bring this formula in because this is actually an example of a 3D Pythagoras, and you can always do this. If I change the sides to A, B, and C, then and it was a cuboid, for example, then the longest diagonal would actually be, the square of it would be A squared plus B squared plus C squared. It's a really nice result. It's used for finding the length of vectors. Thought I'd just show it here, because if you know that fact, you could have literally have written this down right from the start. 25 squared equals 3A squared. Okay, so I've spent a long time talking about it, but if you are familiar with it, you can write that straight down. And why is that useful? Because what is the surface area? The surface area is actually going to be all the areas added up. So this top area is going to be A squared, but all the other ones are going to be A squared as well, and there are 6 of them in total. So actually I don't even need to work back to finding out what A is. I just need 6A squared, and I can times it by 2. So 6A squared is actually going to equal 2 times 25 squared. And I'm nearly done. Of course, you could have solved the equation for A. You could have divided by 3 and then square rooted, and then you could have squared it and times by 6, but I'm actually doing it more quickly here. So it's just going to be 2 times 25 squared, and there we have it, 1,250. This, no matter what, I think is quite a tough question, but if you manage to make that link with the space triangle, then brilliant. If you're happy with it now, then that's great as well. If you understand this thing that I was talking about, then even better.